So today we will start chapter 5. Chapter 5 entitled Thermodynamic Processes and Cycles. So this lecture contains many of the equations we explained in previous chapters. So this, even in the textbook, so whatever we have in this lecture is considered part of in chapter 4. But I prefer to move it with the chapter 5 with the cycles. So you will see a lot of overlapping with the lectures. So this can also be like a good revision and preparation for the exam. So for this chapter, we have 4 points we need to cover. We need to understand what are the classification of thermodynamic cycles. Then we need to start with the ideal cycle, the Carnot cycle. Then we will study real heat engines, real refrigeration cycles, and liquefaction processes. So by end of this chapter, you should be able to analyze single equipments like pumps, compressors, turbine heat exchangers, and we already started like this objective from previous chapter. Also, we need to be able to analyze thermodynamic cycles, see how we can calculate efficiency for these cycles, compare efficiency of ideal or reversible cycles with actual, real, irreversible cycles to see how each one of them can be calculated and see what are the factors affecting each one of them. So for the first point, we will start with classifying the thermodynamic cycles. So we can classify thermodynamic cycles based on 3 things. We can classify the cycles based on the purpose of the cycle. So this is the first basis of classification. We can classify the cycles based on the phase of the working fluid. You remember when we talked about heat engine, we said we have the working fluid. This working fluid gains heat from reservoir source and then release waste of heat to the sink, reservoir sink. So according to the phase of this working fluid, we can classify the cycles we have. Also, we can classify the cycles based on the recirculation that is happening to the working fluid. So these are 3 types or 3 categories. We can classify the cycles based on them. For the first one, if we will classify the cycles based on the purpose, we have 2 types. We have power cycles, we have refrigeration cycles. Power cycles, as you can know from its name, the whole idea for this one is to generate power, is to produce work. An example for this one was the heat engine that we described in previous chapter. And this will be the third part we have in this chapter. We talk about different examples of real heat engines that we will discuss. But this is the first one. So according to the purpose, your purpose in the cycle was producing work, producing power. So it's called power cycles, and an example is heat engine. Purpose can be like refrigeration cycles, similar to refrigerators we have at our homes. So that's this one is we are trying to keep like lower temperatures. And the example is very clear. We have refrigerators. We have some part, or we have part of the system, or we have a region, and we need to keep the temperature of this system or of this region always at low temperature to maintain the refrigeration process. Okay, so this is the refrigeration cycles. So again, power cycles, the refrigeration cycles, they almost have the same components, but the objective is different. Okay, so power cycles, the main objective is to produce power. Refrigeration cycles, the objective is to maintain, like the system, to maintain a certain region at lower temperature. So these are the 2 types of thermodynamic cycles if we will classify them based on the purpose. We can also classify the cycles based on the phase to gas cycles and vapor cycles. And what is the difference between them? So if the working fluid is gas and remain gas with no phase change in the whole cycle, this is called gas cycle. So in this one, we have no phase change. For the working fluid. Vapor cycle, for this one, we have phase change occurs for the working fluid. So phase change occurs means we have the working fluid can enter the first unit as gas or as vapor and exit as liquid or exit as mixture of liquid and vapor. So we have phase change happening for the working fluid throughout the process. But in gas cycles, we have gas, it will go to the first unit as gas, it will exit as gas. The second unit, inlet as gas, output as gas. Third unit, the same. So we don't have any changes happen to the same. It will remain as gas throughout the whole cycle. But if you have phase change happen, it can be vapor as the inlet, and the outlet can be mixture of liquid and vapor. Totally can be 100% liquid, so we have phase change. So now this cycle is called vapor cycle. Clear? The last classification is recirculation of the working fluid. So based on this type or based on these phases, we can classify our cycles into closed cycles and open cycles. So the difference between them, here in closed cycle, we have the working fluid like finish the first cycle, and then the same working fluid will start the second cycle, same working fluid will start the third cycle. So we have complete recirculation happening to the working fluid. In open cycles, you have working fluid like complete the first cycle. Once it finished the first cycle, then we withdraw it and we inject a new fresh working fluid to start the second cycle. Once the second cycle finished, we withdraw this fluid, we inject a new fresh fluid, working fluid to start the third cycle. So here we are changing the working fluid after each cycle. So this is called open cycle. But in closed cycle, there is no need to change the working fluid. Same working fluid that done the first cycle, we'll do the second cycle, we'll do the third cycle, we have complete circulation. But here in open cycle, we are like changing the working fluid or replacing the working fluid with a fresh patch after end of each cycle. But in closed, we have complete circulation happening. So this is the main classification we have thermodynamic cycles. So we can classify them based on the purpose to power cycles, refrigeration cycles. Based on the phase of the working fluid to gas and vapor cycles. Based on the recirculation of the working fluid to closed cycles and open cycles. This is clear?